Hello everyone, welcome to another video. In this video, we're going to discuss the paper 4 of May June 2022, and let's go to question number 1 without wasting much time. So, the diagram of some pieces of apparatus are shown. Name these three pieces of apparatus. So, A is called a burette, A is called a burette, and B is called pipette, and then you have C, that is known as the conical flask. Conical flask. Okay, so what is the reaction that is happening? Potassium manganate is reacting with a solution of ethane dioic acid, and the equation is shown. It looks like a very difficult equation, but it's really not. जो आपने इससे काम करना है, that is pretty easy. So what did you do? You recorded the mass of the sample of solid ethane dioic acid. Then the solid distilled and make up the solution to 250 centimeter cube. Use apparatus B to transfer 25 centimeter cube of ethane dioic acid into apparatus C. Now add 10 centimeter cube of sulfuric acid to apparatus C. Fill apparatus A with the solution of KMnO4. So basically, in the burette you have added KMnO4. In the conical flask you have added the acid. So you do titration until the endpoint is reached, and then you repeat the titration 3 times. Let's suggest. Okay, 10 centimeter cube of sulfuric acid की apparatus C में हमने डाला. Before, like we used apparatus B, a pipette, to transfer ethane dioic acid into apparatus C, and then we also added sulfuric acid into it. Why did we do that? Ethane dioic acid is a carboxylic acid, which means it's a weak acid. So we added some volume of sulfuric acid to increase the amount of hydrogen ions. Okay, so why do we add sulfuric acid? We added it to increase or to provide H plus ions. State the color change at the end point. Okay, so you're adding KMnO4. KMnO4 will change from colorless to pink. It changes from colorless to pink. Okay, now this titration 1 is being shown here. You need to plug in the readings. So, titration number 1. Initial reading is 1.5, 1.6 and 1.7. Initial reading is 1.7. Final reading is 27.1. And the volume used would be 27.1 minus 1.7, 25.4. You will also need to plug in the remaining readings. So for titration 3, you don't know the volume. So 20.9 minus 0.8 would be 25.1. And then you have the final reading. You have the volume, use it, subtract them, and you will know the initial reading, which was 0.3. Now take the best titration results in the table. Best titration results will be those which will be closest to each other. So which one is the closest? You have 25.4, 24.8, 25.1 and 24.6. So 24.8 and 24.6 are actually the closest. So you will take these two and use the tick values to calculate the average volume. Now you'll have to calculate the average volume, which will be 24.7. We'll just add them together and divide it by 2. Okay, the next part is calculate the number of moles of ethane dioic acid in 25 centimeter cube of this. Okay, moles निकालने हैं. So you have what? You have calculated the moles of KMnO4. No, you have calculated the volume of KMnO4. So the student uses 1.08 grams of ethane dioic acid. So he has given you the mass of ethane dioic acid. So we just need to calculate the moles of ethane dioic acid. So moles will be equal to mass over mR. So 1.08 divided by mR. You will get 2 marks for this. 1 mark is for mR and the other mark is for the moles of what was it? Ethane dioic acid. So you have 1.08 divided by 90. In fact, no. You will get the whole 2 marks for the number of moles because mR is already given to you. So the answer would be 0.012. Okay, in question in the part 2, during the reaction 2 moles of KMnO4 react with 5 moles of H2C2O4. Calculate the number of moles of KMnO4 in this volume of potassium manganate. So you are given the ratio when there were 2 ratio 5. KMnO4 2 and 5 moles of acid. So when there are 2 moles of KMnO4, there are 5 moles of acid. And if there are 0.012 moles of acid, 0.012 moles of acid, how many will be the moles of KMnO4? So you'll cross multiply, and X will be equal to 2 into 0.012 divided by 5, and the answer would be 0.00048. Okay. Okay, now you need to calculate the concentration. Moles is equal to concentration into volume, and concentration will be equal to moles divided by volume. So moles are 0.0048 over volume. Volume is 24.55. It's in centimeter cube. You are required to calculate concentration in decimeter cube. So you will divide the volume by 1000. So 24.55 divided by 1000. So the answer would be 0.0196, right? So the next part is you need to calculate the concentration of KMnO4 in gram per dm cube. You just calculated the concentration of KMnO4 in mole per dm cube. To convert from mole per dm cube to gram per dm cube, you will have to multiply with the MR. You should already know that to convert gram per dm cube to mole per dm cube, to convert gram per dm cube to mole per dm cube, you actually divide by MR. And if you're going the other way, mole per dm cube to gram per dm cube, then you'll have to multiply with MR, and they have given you the MR. So 0.0196 multiplied by 158, the answer would be 3.09. A solution contains, it's a second question, a solution contains one cation and two different anions. The table shows the test a student does on the solution. Complete the table. Okay, so the conclusion is the cation might be aluminium ion. And what did you add? You added sodium hydroxide, and so aluminium ion would give white precipitates. Aluminium ion would give white precipitates. And then you added excess sodium hydroxide. Okay, so the cation might be aluminium. For aluminium, white precipitate dissolve. So white precipitate dissolve in excess. And what will be the other cation? Okay, whatever you name here, you'll have to write the observation accordingly. Okay, for example, if I write that zinc ion is being formed, right? तो आपने लिख दिया dissolve in excess, right? And when they dissolve in excess, they form a colorless solution. Basically, both of them actually dissolve to form a colorless solution. Only calcium ion does not dissolve in excess sodium hydroxide, if I remember it correctly. Now you don't really have to remember these things, and I don't think that this kind of question is going to come in exam anymore, because they have already given you, because they'll provide you with all the identification of ions tables. It's going to be a bit more analytical, but obviously we are going to practice these questions. So just practice them by memorizing these tables, because you'll have to memorize them anyway for paper 1 and paper 2. Anyway, now the next one is the cation is aluminium ion, and you added aqueous ammonia to it. And what would aqueous ammonia do? Obviously, white precipitate will be formed, white PPT, and then you add excess ammonia, and in excess ammonia, aluminium is insoluble in excess. So insoluble in excess. Okay, so then the gas and the anion you have to identify, and the test is that you added nitric acid and you warmed it from nitric acid. Okay, and the gas that is evolved decolorizes acidified potassium manganate. There's only one gas that decolorize an oxidizing agent of potassium manganate. That gas is sulfur dioxide. Sulfur dioxide. And one of the anions is, these are the anions. This is sulfide ion. Okay. For sulfide ions, you basically use this. And to the solution from 3, add aqueous silver nitrate in the yellow precipitate forms. The another anion will be silver iodide. Silver iodide is yellow in color. Okay, ji. So let's move on to the next part. Okay, great. Mm-mm-mm. Okay, ji. So the B part says that a mixture of solids contain barium sulfate and sodium chloride only. So barium sulfate is insoluble and sodium chloride is soluble. It's just a fancy way of asking you how to separate sand and sodium chloride. So barium sulfate is insoluble in water, sodium chloride is soluble in water. They told you that they are kind. It's really kind of them that they told you. Describe how to separate the mixture to obtain pure barium sulfate and pure crystals of sodium chloride. So you have solid barium sulfate, an insoluble thing and a soluble thing together. The first thing you will have to do, you'll have to add water. You'll have to add water to the mixture. Okay. Add water to the mixture. Now, barium sulfate will not dissolve, but sodium chloride will dissolve. Now, you'll have to separate barium sulfate first. So, what will you do? Once you have added it, obviously, you'll have to shake or stir the mixture, right? And then once you're done with that, you'll have to separate the barium sulfate. Since it's insoluble, you'll have to filter the insoluble barium sulfate. Filter the insoluble barium sulfate. And most of the students, a lot of the students just leave barium sulfate here. Now you'll have to prepare pure barium sulfate. So be done with it first. Once you've filtered it, you will have to wash it. What do we do with insoluble salts? We wash them with distilled water. Wash with distilled water, and then you'll also have to dry it. Wash with distilled water and then dry the precipitates. Not dry the precipitate, but dry. You can say wash the residue. That's a better word. Since you're doing filtration, it's good to use filtration technical words, right? And you can dry the barium sulfate between folds of filter paper. Between folds of filter paper. You've already scored like 4 marks until here. Now you'll have to separate sodium chloride. Now the remaining solution, which is the filtrate, use the word filtrate. Then you'll have to heat it since it's a soluble salt. So you will write heat the filtrate to crystallization point, or you can also say that heat the filtrate to the point of dryness, to crystallization point, and then you can simply heat the filtrate to crystallization point to get sodium chloride crystals. Let's be more specific. And then you can simply dry the sodium chloride crystals in a warm oven or between folds of filter paper, whatever it is. Okay, so write the full process. The key to planning questions is that whenever another person reads it, you have to be so specific. You have to be so detailed that your answer should give instructions to any other person who wants to do this experiment. Okay, it should be that clear. That is the idea of it. Okay, let's move on. A student measures the temperature change during the reaction between HCl and sodium hydroxide. So the student uses a measuring cylinder to add 25 centimeter cube of this concentration of sodium hydroxide to a glass beaker, and he records the initial temperature of sodium hydroxide, and then he added some HCl to it and records the highest temperature that is reached. He then adds further 4 centimeter cube portions of the HCl. So he added 4 centimeter cube, then he added another 4, another 4, another 4, and then they recorded the temperature changes. Okay. So name the type of reaction that takes place between HCl and NaOH. Since the temperature is increasing, it has to be an exothermic reaction, right? The temperature of the surrounding is increasing. The surrounding is the beaker and the stuff, right? So it's increasing, so the reaction would be an exothermic reaction. Name a piece of apparatus that can improve the accuracy of the volume of NaOH added to the beaker. Did he mention any apparatus? No, he did not. But you should know that the most accurate pieces of apparatus, which is pipette or burette. You can use either pipette or you can use a burette to improve the accuracy of the volume measurement. Name the piece of apparatus used to add the 4 centimeter cube portions of HCl. So this is most likely going to be titration, right? Because you are reacting alkali with an acid, right? So you are adding 4 centimeter cube HCl is most likely going to be a burette because you already added uh, sodium hydroxide to a glass beaker, right? And then you added HCl. And when you added HCl, obviously, you'll have to add it from a burette. Explain why the glass beaker is not the most suitable piece of apparatus for this experiment. It should have been a conical flask. Or you can, no, well, in fact, why glass beaker is not the most suitable? Most likely it's going to be because since you're recording the temperature, so it's best that heat is not lost in this reaction. So since it's using a glass apparatus, so glass apparatus would not block the heat loss, right? So explanation is suggests an improvement as well. Okay, explanation is that it is not the most suitable because heat will be lost. Heat will be lost to surroundings. That is the problem with the glass beaker. What you can do is you can use uh, an insulation material like polystyrene cup, or you can also insulate the beaker as well. You can insulate the beaker, or you can also use an insulated material, a non-conducting material like polystyrene cup. You can also use a polystyrene cup. Okay, now you'll have to plot it. So temperature is on y-axis and volume is on x-axis. Now let's plot it. Okay, so I plotted the points. At 0 it's 24.5, at 4 it is 25, at 8 it's 28.5, and then I hope you know how to plot these diagrams. Uh, in the specimen paper 2023, there is no interpretation question, like there is no graph or plotting question, but that does not mean that it will not be tested. What I feel is that from the specimen paper, the type of question that was there for identification of ion, I think that that is the kind of question that they're going to give in the final exam as well. But as far as the other questions are concerned, there is still a 50-50 chance on the moles. But interpretation question can be there. Just because they didn't, because they can only make one specimen paper, so they cannot include all types of questions. So there is going to be a planning question. There is going to be, I strongly feel that there is going to be an interpretation question, a plotting question. Okay, so plot the values of temperature against total volume. I just did that. Circle the anomalous point. Anomalous point is this one. It's not following the trend here. Draw a straight line of best fit through the points from 0 to 16. I don't have a scale here, so we'll have to draw a straight line from 0 to 16 like this. Okay. In fact, just draw it 0 to 16. So let's stop it there. I actually extended the line. Let's not extend it until he asks you. Okay, like this. And draw a straight line of best fit through the points from 20 to 32. Okay, this will be like this from 20 to 32. You'll use the scale obviously. And then the third point is he's asking you to extrapolate both lines so they can intersect. Okay, now you can extrapolate this and like this. Okay, obviously there's going to be some error for me because I don't have a scale here. My stylus is not working. I would have otherwise used the scale. So use the intersection to determine the minimum volume of HCl needed to react with all of NaOH. So that is basically the intersection point. If you just uh, drop down from here, this is the line that is coming. Na? This is coming at 18, but it's actually 17.4. 17.4 is something over here. This is 17, right? It will come somewhere here. Okay, because I haven't drawn the straight lines, that's why there is a slight error. So the answer is actually 17.4. If you guys do it, I'm sure आप लोग निकाल देंगे. Use the intersection to determine the temperature change due to the reaction. So to calculate the temperature change, आपने intersection use करना है, उसने आपको खुद ही बता दिया. So this was your initial temperature 24.5, and this was your the highest temperature, which is around 33.2. Okay, so 33.2 minus 24.5 would be 8.7 degrees. 8.7 degrees. Now the heat change during this reaction is calculated by using the expression shown. Heat change is equal to mass into specific heat into temperature change. हो सकता है आपने physics में ही पढ़ा भी हो that Q is equal to mc delta T. Okay, so they have given you the mass of it. Determine the value used for the mass of solution in this calculation for this heat change. तो सिंपली आपने मास कैलकुलेट करना है सोल्यूशन का. तो सोल्यूशन में आपने क्या क्या डाला था? NaOH और HCl. तो NaOH आपका था 25 जो आपने ओरिजिनली लिया था, और HCl आपका कितना यूज हुआ था? यू जस्ट ड्रॉप्ड इट डाउन एंड यू कैलकुलेटेड कि वो कितना था. इट वाज 17.4, राइट? इतना यूज हुआ था. तो इन दोनों को ऐड कर देंगे तो आपका आंसर आ जाएगा 42.4. So the actual heat change of this reaction is much greater than the value calculated. Suggests a reason for this difference. Same reason, that heat is being lost because you use a glass beaker. Na? So obviously the glass instrument that you're using is conducting. It's going to conduct heat. So heat is being lost. That's why there is a difference between the actual value and the calculated value. So because heat is lost. So question number 4 states as there is an apparatus shown. We are doing electrolysis of dilute sulfuric acid. The electrodes are made up of platinum. Give the name of each electrode. So positive electrode is known as anode, and negative electrode is known as cathode. If you struggle to remember this, just remember panic. PANIC. Positive is anode, negative is cathode. Okay, the equation for the reaction at the positive electrode is shown. Give the equation for the reaction at the negative electrode. Okay, so you're basically electrolyzing H2SO4. At the negative electrode, the positive ion will go, that is the hydrogen ion. So hydrogen ion will gain electrons. Electron is always gained on the left, and we know that hydrogen does not exist as an atom. You will have to write it as a molecule whenever you're writing it individually. So 2 hydrogen atoms or 2 hydrogen ions will also gain 2 electrons. Okay, so next is the stripe test used to identify gases produced. So oxygen's test is you basically use a glowing splint. Use a glowing splint for the test. And what is the observation? When you expose it, when you expose the glowing splint to oxygen, it relights. Okay, and the other one is hydrogen. The test is you use a burning splint. A burning splint, and the observation is it produces a pop sound. A pop sound. Sometimes sound nahi aata, but there is still a flicker, a pop. Okay, ji. So this is like the famous reaction of carbonate with an acid. Identify the piece of apparatus labeled as X. This is called the gas syringe. Okay, the student starts the reaction by tipping the sample tube so that the copper carbonate and acid come into the contact. He's talking about this. He will tip, he will pull this thread and the sample tube will tip, and he'll pull the sample out. I mean, he'll pull that sample tube out, or ये जितना भी आपका calcium carbonate होगा, calcium carbonate will fall into the beaker or fall into the conical flask. Sorry. Explain why this method is used instead of adding copper carbon to the acid and then replacing the bond. If you do that, if you add the carbonate and the sulfuric acid and mix them, and then place the bung, that would cause a loss in carbon dioxide. You are collecting carbon dioxide, you don't want it to lose it to the atmosphere, huh? So that's why you use this thread. You use this method to avoid loss of gas. To avoid loss of gas. No matter how fast you apply the bung, there will still be a chance that some carbon dioxide escapes, right? Okay, the next part of this question is the student takes a reading on the apparatus X after every 10 seconds. So he's collecting the volume of gas after every 10 seconds until the reaction has stopped. And he has plotted the graph of the he's plotted a graph of the results. Let me just zoom out a bit. Okay, so give the labels for each axis of the graph. What's the horizontal axis and what's the vertical axis? You should know that horizontal axis for the rate of reaction is mostly time, and for this curve particularly. And on the y-axis, we already know that he's collecting the volume of gas. So you can write volume of gas collected, or just volume of gas, or even just volume. So write time here. I'm writing write time here and volume in this blank. List three things the student sees happening in the flask during this reaction. सबसे पहले carbon dioxide is being released, right? So there will be effervescence. Secondly, you are adding solid sodium carbonate in the acid, so solid will be disappearing. So you can write solid calcium carbonate, or was it copper carbonate? I don't remember. So it's copper carbonate. So solid copper carbonate disappears, and effervescence is seen. Effervescence can be observed. And since copper carbonate is reacting with sulfuric acid, so copper sulfate is being formed, and copper sulfate is blue in color. So you will also write that the solution turns blue. Okay, so these kind of questions can still come in the paper 4 even after the specimen paper bomb that they have actually detonated on you. Okay, the most, like I already told you, except for the moles question and the identification of ions question. Okay, all the other questions are still intact. They can still come in exam. The planning question is always there. Interpretation question, they have, with the specimen paper, they've actually shown that to us that they can choose between the interpretation question or any other question they have given in the specimen paper. Okay, but interpretation question can come. Interpretation question used to come in every paper because it used to be a 60-mark paper, and now it's a 40-mark paper. So obviously they're going to reduce the number of questions and the number of topics and the number of type of questions that are going to be tested. So don't worry about it. The only uncertainty most students are going to have is what is going to happen with moles, and how much will, if it's not tested in paper 4, how much of it will be tested in paper 2. But the bottom line is you'll have to do moles. If you need to score an A, you'll have to do the moles. Okay, so अब तक के लिए इतना ही. Inshallah, I'll still see you in the next video.